This video will contain mesh analysis with dependent sources. Like your analysis in dependent sources in your nodal analysis, your dependent sources will be dependent to a passive element, which is usually a resistor in this DC circuit. So I will indicate that this will be your mesh analysis. So let's have a circuit which is 24 volts connected in a 250 ohm resistor to then another 50 ohm resistor and a dependent voltage source, which is a current dependent voltage source. Why I have said that it is a current dependent? So you can see that this is a voltage source which is 60 IV. This IV means it is a current dependent voltage source. Okay, another 150 ohm. Okay, so find or determine IB in the circuit. So determine IB. In the figure, your IB is here. It is not assumed, it is a question. Okay, determine IB using mesh analysis. So how will we do it? So take note that our first step in solving for your mesh analysis is to create our loops. So I have already, this will be my loop 1 and this will be my loop 2. Okay, I will change the color so that I will identify it will be identified better. Okay, so this will be my I1 and this will be my I2. Okay, so as you can see that I have already identified the loop direction or the current direction of the loop. It is a clockwise direction. Also, I want to identify that this is I1 at this mesh. So I1 and I2 it of each mesh. Okay, so I1, since I1 is with the same direction of IB, I may say that my I1 is equal to my IB. Okay, and then also we have a passive element which shares a current with other element. So if I will go with the loop I1, so I will call it as I12. So as I have said in my previous videos that I is the original current, which is again which is which is affected by your I2 current. But if I will consider my I2 loop I2, so therefore at loop I2 I will consider it as I12 at 50 ohms will be equal to negative I12, because I will consider I21, which means that it is the original current of 2 and then current I1 will be affecting the loop current. Okay, which is I21 is the negative of I12 based on our vector notation. Okay, so in our mesh analysis, I already described my loops and also I will describe the direction of my current. So I12 and then I12. Okay, I2, this is my I2 and this is my I1. Take note that my I12, so this will be our node A. So KCL at node A, at node A, at ito spelling yung node natin at node A, so we have going into the node your IB or your I1, and then going out the node is your I2 and your I12. So negative I12 equals 0. Therefore, I may say that my I12 is equal to I1 minus I2. That is our current I12 equivalent in I1 and I2. So let's have a mesh analysis or your KVL analysis. This is a continuous KVL. So we have our equations. So setting our equations, setting equation at loop 1. Okay, this will be our loop 1. Okay, so what are the resistors that can be found in our loop 1? So we have 250 multiplied by our I1. Okay, so ilalagay muna natin sa voltage na lang. So since KVL siya, using KVL at loop 1. At loop 1. Okay, so we have negative 24 volts kasi pumasok sa negative, plus voltage at 250 ohm, plus our voltage at 50 ohm. Take note that if it is a resistor, assume na pag hindi mo binaligtad yung current mo, it is always positive, because take note that our resistor is a passive element which absorb power. So equals 0 via conservation of energy. So our V150 is just equal to V250 is equal to what? 250 multiplied by I1, since it is with the same direction of our I1, and our V50 is equal to 50 multiplied by I12, since it is with the same direction of our V50 I12. So we have negative 24 plus 250 I1 plus our 50 I12, which is equal to 0. Okay, take note that our I12 was described as I1 minus I2. Alright, so we have negative 24 plus 250 I1 plus our 50 multiplied by I1 minus I2 equals 0. Okay, so we have our first equation, which is equal to negative 24 plus 250 I1 plus our 50 multiplied by I1 minus 50 multiplied by I2. So we have 300 I1 minus 50 I2, which is equal to 0. So our first equation will be equal to 300 I1 minus 50 I2, which is equal to 24 volts. Okay, so this is our first equation. So by inspection, so as I have said in our previous videos, that you can actually find the value of your resistor easily by inspecting. Okay, so take note na lagi ko sinasabi na pag yung resistor mo nakakonekta sa buong loop, therefore i-add mo lang siya, then use that current which is with the loop current that you are using. Okay, so 250 plus 50 multiplied by I1, so that is your 300 I1 minus yung resistor na nakakabit sa kabila, so multiplied by nung current nung nasa kabilang mesh kung saan siya nakakabit, so minus 50 I2. So using our KVL as a guide, so negative 24, so magiging positive 24. Ganun lang kadaling mag-setup ng equation of mesh analysis. So i-add mo lahat ng mga resistor na nakakabit sa loob ng mesh minus yung mga resistor with the current of that particular mesh na nakakabit sa kabilang mesh. Okay, so in this case, this is the resistor, total resistor na nakakabit sa loop 1 natin, minus yung resistor na nakakabit sa kabilang mesh natin multiplied by the current within that another mesh, okay, which is your I2. Okay, kaya lang kadaling i-set up yan. This is an explanation on how to set up that equation. Okay, next is that we will use the inspection method in order to set up your second equation. So KVL at loop 2, we have positive 60 IB. So kasi pumasok tayo sa positive 60 IB, so positive 60 IB. Okay, plus all the resistors that are connected directly in that loop. As we analyze that loop at loop 2, so we will use our loop 2 current, which is I2. So 50 plus 150 is equal to 200 I2. Okay, 200 I2. we have our 200 I2 minus the current na nakakabit naman sa kabila, which is 50 I1. Take note na kung ano yung loop na ina-analyze nyo, yun yung magiging positive, and yung negative is yung loop kung saan nakakabit yung isang resistor, which is particularly your 50 ohms. Okay, you may prove that using our previous equation, wherein you would substitute the value of your I12 is equal to, or your I21 is equal to negative I12. Bakit? Kasi nga, pag nag-analyze tayo ng I2, so magiging ganito na yan. Babaliktarin mo yung I12 mo, which is I21, the current in your mesh 2, that is affected by I1. So magiging I21 siya. Babaliktarin mo yung I12 mo kasi yung I21 mo is kakasalungat niya yung I12 mo. Okay? So, like I have said, your subscript will tell you what to do. Okay? So, pag binaliktad mo yan, mapapansin mo na magiging kwan siya. So, magiging voltage at 50 ohm mo at loop 2 will be equal to 50 multiplied by I21, which is equal to 50 multiplied by negative I12. So, which is equal to 50 multiplied by our negative I12 is we have I1 minus I2, so negative niya. So we have 50 equals I2 minus I1. Okay? So, pag nag-KVL tayo sa loop na yan, makikita nyo na we have positive 60 IB, which is your voltage which is dependent to IB, plus our 150 multiplied by I2 plus our 50 multiplied by I21. Okay? So, makita nyo na magiging 50 IB plus 150 I2 plus 50 multiplied by I2 minus I1, which is 60 IB plus 200 I2 minus 50 I1. Okay? Na masaset up nyo gamit yung sinasabi yung shortcut, which is lahat na nakakabit sa mesh na yan, multiplied it at a loop that you are analyzing minus yung another resistor na nakakabit sa kabilang mesh current. Okay? So, ito yung second equation natin, but take note that we have an equation or your IB, a variable IB, which is, take note that I have identified that our IB is equal to our I1. Okay, so therefore I may say that we have, since IB is equal to I1, so I may say that it is equal to 60 multiplied by I1 plus 200 I2 minus 50 I1 is equal to 0 tayo. May 0 tayo dyan. Okay? Okay? So, we have this equation. Since meron na tayo nyan, so, ano next na gagawin natin? So, we analyze and substitute your 60 I1 plus 200 I2 minus 50 I1 equals 0. So, next is that we will further manipulate the equation. So, we have 200 I2 minus plus 60 minus 50 is 10. I1 is equal to 0. So, we have 10 I1 plus 200 I2 is equal to 0. That will be our second equation. Okay? So, what would be the next? Okay. So, meron tayong equation 1. Then, we already have our equation 2. This is our equation 2. Pwede natin gawin yan, dalawa. Pwede tayong mag-calculator or pwede lang tayong mano-mano. But particularly, since sa bahay kayo, alam magmamano-mano sa inyo, okay? So, ang gagawin natin, magka-calculator kayo. So, mode 5, 1 for 991 ES users or 570 ES users. So we have our equation 1, we have I1 which is equal to 300. 300 I1 equals negative 50 equals 24. So ilalagay nyo lang yan sa natin, sa calculator natin, and then we have our 10 I1 plus 200 I2. So therefore, we have our I1 is equal to 0.0789 ampere, or it is equal to 78.9 milliampere. Okay, pag ginamit yung scientific notation natin. And then our I2 is equal to negative 3.947 times 10 raised to negative 3 ampere, or it is equal to negative 3.97 milliampere. Okay, so in order to be convinced with the answer, so I will show you using our calculator. Okay, so our calculator, so we have mode. So iba ito, no? Kasi I suggest na pag may phones kayo ng Android, so gamitin nyo na lang to. So simple lang naman siya. Ito yan. So we have 300 equals negative 80 equals 24. Okay, and then another we have 10 equals 200 equals 0. Okay, real quick. So we have our current which is equal to 0.789 ampere, that is for your I1. And then your I2 is equal to negative 0.03947 ampere, or 3.94 milliampere. That is for your I2. Okay? Right? So this is our I1. But the question is, determine the IB. So what is your IB? So take note that your IB is equal to your I1. So therefore I may say that your I1 is equal to IB. So it is equal to 78.9 milliampere. Okay? 0.0789. So kung mahirapan kayo, type nyo ng 0.0789 and then click ENG. You will have the scientific notation of your 78.9 ampere, which is 78.9 milliampere. Okay, so that is our solution for a dependent source. Take note, that is a dependent current source because it is dependent with current and it is a voltage source.